Today we're on section 11.1. It's exponential and logarithmic functions. And before we start, we're going to do a little bit of review on exponents and what you do with the exponents. If I have like a to the m power times a to the n power, you know if the base numbers are the same, you just add their exponents. If I have a power raised to a power, like m raised to the n power, I just multiply the exponents. If I have a quotient, let's say I have m to the n and a, or a to the m and a to the n, I subtract the exponents. Now every one of these, the base has to be the same on to do it. If I have a b to the m power, that's the same as a to the m power times b to the m power. And if I have a exponent, let's say I have a m raised to the b power, then that b is on both the a and the m. Okay, these are all things that you should already know how to do. We're going to work on some just to refresh your memory on these. Say I have 2 to the 4th times 2 to the 8th over 2 to the 5th. On the top, that's multiplication. The base numbers are the same, so that's 2 to the 12th power over 2 to the 5th power. I'm going to subtract my exponents, and I'm going to place it in the position of where the larger exponent is. So 12 minus 5 is equal to 7. So my answer is 2 to the 7th power, and it's on the top. If I want to put a 1 underneath it, I can. Or, of course, I can leave off that 1 because the 12 is on the top. What if I have something like this? 2 to the 2 over 5 raised to the negative 1 power. That's the same as saying 2 to the negative 1 over 5 to the negative 1. Remember, the negative exponent means it's in the opposite location. So to get rid of the negative 1, I'll take the 5 to the top, and that's 5 to the first. To get rid of the negative 1 on the 2, I'll take the 2 to the bottom. So that becomes 2 to the first, or simply 5 over 2. All right, another one. I have powers raised to the power, so I multiply 5 times 2 and get s to the 10, 5 times 3, and get t to the 15th. And that's the answer. What about this one? Right, can't do anything in the top yet, so x to the 3rd y. The bottom I'm going to multiply. It's going to become a 12. The only thing I can do is reduce this. 12 minus 3 is 9, and it would be on the bottom because my larger power of the x is on the bottom. So that would be my final answer there. All right, I'm going to give you a few to try. You come back and check your answers. I hope you can still see all of them in the vision on the board. All right, go ahead and do those, pause the video, and then come back. All right, working our way through this. This is going to be 3 to the 11th power over 3 to the 6th, which is equal to 3 to the 5th. This one, these two are going to flip-flop, so it's going to become 4 over 3. This one I'm going to multiply, so I have s to the 12th, t to the 21st. This one I'm going to have to do the bottom first, so the top doesn't change yet. And the bottom is x to the 8th. So I'm going to have y to the 5th over x to the 6th. All right. Now, if you remember right, when you have exponents that are fractions, it is basically expressing a radical expression. So in other words, if I have 125 to the 1/3 power, that's the same thing as saying the cube root of 125. The cube root of 125 is 5. Sometimes it helps you to do problems out. So let's say I have the square root of 14 times the square root of 7. I go, okay, well I could multiply those out and then I could break it down. But an easier way to do it is go 14 to the 1/2 power times 7 to the 1/2 power is the same as saying 2 to the 1/2 power times 7 to the 1/2 power, because that's what 14 is equal, times 7 to the 1/2 power. Well, this stays like that, but this, the base numbers are the same, so I add the exponents. 1/2 plus 1/2 is equal to 1, so this is equal to 7 on the square root of 2, because that still has the 1/2 power on it. All right, let's do a couple more here. All right, I have 81c to the 4th raised to the 1/4. That's the 4th root of 81c to the 4th. Probably the easiest way to do this is to go, oh, well that's 3 to the 4th, c to the 4th, raised to the 1/4 power. So now I multiply my exponents. So that's just going to give me 3c, because it'll give me 3 to the 1st and c to the 1st. One more, and then I'm going to give you a couple to try. All right, doesn't look like I can do anything here, so what I'm going to do is I'm going to raise this to the 1/6, and I'm going to raise this to the 1/6. This is the same as 3 squared to the 1/6 power, x cubed to the 1/6 power. I'm going to multiply my power, so 2 times 1/6, that's going to end up giving me 3 to the 1/3, and this is going to give me 3 to the 1/2. So this is the cube root of 3 times the square root of x. Okay? All right, now let me give you a few to try. Go ahead and work them out, pause the video, and then come back. So pause the video and then come back to it. All right, this is the same as 5 to the 4th raised to the 1/4 power. So I get 5 as an answer. This one, I'm probably going to break down into 3 to the 1/2 times 3 to the 1/2 times 7 to the 1/2, because 3 times 7 is 21. These two, when I add the exponents, is equal to 1, so I have 3 on the square root of 7. Over here, I'm going to write this as 3 to the 3rd power raised to the 1/3, because 3 to the 3rd is the same as 27, times a to the 6th raised to the 1/3. This is going to give me a 3, because 3 times 1/3 is 1, and this is going to give me a 2, because 6 times 1/3 is 2, so 3a squared. This one I would write out 8 to the 1/6 times x to the 12 to the 1/6. I'm going to take that 8 and make it into 2 cubed to the 1/6 times x 12 to the 12 to the 1/6. This is going to give me 3 over 6, or 1/2, so 2 to the 1/2, and that's going to give me x squared. So that would give me x squared on the square root of 2. And those should be your answers to the ones that you did out. So make sure you got those right. All right, continuing on here. B to the m over n power can be written as the n root of b to the m power. Hopefully that's just review. So if I have 625 to the 3/4 power, that is the same as the 4th root of 325 cubed. I think if I were you, I would do it with exponents though, because I would say that's 5 to the 4th power raised to the 3/4 power. When I multiply that, I'm going to get 5 cubed, or 125. What if I have something like this? Okay, I know that the base number is the same, so I can subtract the exponents. So I have 3/4 minus 1/4, which is 2/4, or 16 to the 1/2 power. Well, you might want to just go the square root of 16 is 4. You could look at that as 4 squared to the 1/2 power, which is simply 4. All right, now what they're going to do is they're going to give you a radical, and then they want you to express it as exponents. So here's your radical here. All right, so what I'm going to do is I'm going to take this 3 and I'm going to make it 1/3. So I'm going to have 64 to the 1/3 power times s to the 9th to the 1/3 power, because they're telling me to write it as exponents. So I'm taking this radical, or what we would call the radical expression, and I'm making it into an exponential expression. All right, this one I want to rewrite. That's 4 to the 3rd power to the 1/3. Oops. And that becomes s to the 9/3, and this would become t to the 15/3. This is going to be 3 times 1/3, or just 1, so that's going to be 4. This is going to be s cubed, and this is going to be t to the 5th. All right, then sometimes they're going to do the other way around. They're going to give it to me in exponents and tell me to write it as radicals. All right, the very first thing I want to do though is I want to try and get a common denominator here. If I can get a common denominator, then what I can do is I can write it under one radical expression. So 3 and 2 both go into 6, so I'm going to rewrite this with a 6 on the bottom, so that's going to give me 4, 6. 6 on the bottom here is going to give me 3, 6. Now I can write it as 12 on the 6th root of x to the 4th, y to the 3rd. If the bottom numbers don't match up, I can't put it underneath one radical, because up here is a cube root and here is a square root. So I can make them into a 6th root. All right, I'm going to have maybe you try a couple of these. All right, make that into a radical, and then let's actually no. I'll give you another one to do. Express this one. Express that one as a radical right there, and then go ahead and express this one using exponents. Pause the video and come back to it. All right, what I would do is I would put a common denominator here, and that common denominator would be 4. So that's not going to change, but this becomes 2/4. So what I have is I have 5 on the square root of x cubed, y squared. Down here, I have 16 to the 1/4 power s to the 12th to the 1/4 power, and t to the 16th to the 1/4 power. This is going to be the 4th root of 16, or maybe 2 to the 4th power raised to the 1/4. So that's going to be a 2. This one's going to be s cubed, and that one's going to be t to the 4th. And that's where you're going to stand on that. All right. Then you might have some that you have to simplify. So let's say I have the square root of x, or r to the 7th, s to the 25th, and t to the 3rd. And I would show you a shortcut on this. I wouldn't do it the way that the book necessarily recommends to do it. There's an understood 2 here because it's a square root. So I want to know 2 times what is equal to 7 without going over it. Well, 2 times 3. So I have r to the cube out here, but I can't get all the way to 7. I can only get to 6. So I have one more r right here. 2 times what comes close to 25 without going over it? That would be a 12. So 2 times 12 is 24, which leaves me with one s still underneath the square root. 2 times what comes close to 3 without going over it? 1. So I have t to the 1st, but I still have another t underneath. And so that's your simplified form. You try one. You try this one. So try it and then come back to the video. All right, this is going to be 2 times 3. So I have an r cubed out here, but I still have an r left. I have a 2 times 2, so I have an s squared, but I still have another s to get to 5. 2 times 12 gets me directly to 24, so I have a t to the 12th out here. Don't have any more t's, so this is your answer for this last one. All right, last part of this section has to do with solving equations. So you're going to take all this information and you're going to apply it to equations. First thing I'm going to do is I'm going to add a -5, so I have 729 is equal to x to the 3/4 power. I probably would go ahead and raise both sides to the 4/3 power to get rid of that. Okay, you actually can do that on your calculator. Don't forget about the raise button, and then you can put 4/3 in parentheses. And it gives me 6,561, and of course this right here is equal to x, because 3 times 4 is 12, 4 times 3 is 12, so I have 12 over 1. All right, you try one, and then I'll give you your homework. Go ahead and try it, pause the video, and come back. All right, this is going to be 625, because I'm going to add the 9. I'm going to multiply or raise both sides by the 5/4 power. That gives me 1/1 or 20/20, so I have x here. When I do that on my calculator, I get 3,125. All right, your homework is page 700 to 701, 20 through 66, even.